Okay, so let's see what we're looking at here. We're on IXL, find the constant of variation. All right, let's look at it. This graph shows how the amount of dough Ellen has prepared is related to the number of hours she has spent working at the bakery. Okay, that makes logical sense, right? We're talking about a bakery and working. The more hours worked, the more dough she makes. Makes sense. It's asking us, what is the constant of variation? Okay, so what does that mean? It means that we are looking at direct variation. We know that because this graph starts at the origin and it's a straight line. So we know it's direct variation. But it's asking us, what is the constant? If we remember, the constant is the K in this formula. It's that number that we're going to multiply times every X value, and it will always equal the Y value. That means it's constant or direct variation. And so that means that we're going to take some number and multiply it by however many hours she worked, and that will tell us how much dough she made, how much dough she prepared, okay? So how do we find that K? To do that, I always start with making a table. So to make a table, the table is just another way to organize our data points, our coordinates. It's just another way to show our X, Y combinations. And so we're going to look at our graph to find those X, Y combinations. We have 0, 0. Obviously, if she works 0 hours, she doesn't make any dough, right? Now we'll follow along the graph, and so we'll see that it also crosses here. So when she works 2 hours, she makes 3 things of dough, 3 kilograms of dough, I guess. So 2 hours, 3 kilograms of dough. Also, when she works right here, it looks like 4 hours, she makes 6 kilograms of dough. So 4 hours, 6 kilograms of dough. All right, so that's great, but how do I find the K? Well, in any formula, if there's only one variable, you can solve for it. Now stick with me here for a second. I'll make it easier at the end, but just try to follow along. If I plug in an X value, one of the X values that I have for the X, and one of the Y values that I have for the Y, then I can solve for or figure out the K. So when I plug it in, it'll be K times the X, K times 4, some number times the 4. That's a weird looking thing, but you'll figure that out. Is going to equal our Y. Well, K times 4 equals 6. So we got to figure out what that K is. And the goal is to get K by itself. We want it to look like this. K equals some number. We don't have that yet because we have K times, we don't have that yet because we have K times 4. So to get rid of the K times 4, we have to do the opposite operation. So we're going to do the opposite operation of times 4, which is to divide by 4. And the reason for that is because if we do 4 divided by 4, anything divided by itself is just 1. So this is now going to be just K times 1, which is just K. Cool, so K is by itself. But I can't just like change this equation and just throw in division signs. I have to do the same thing to both sides of the equation. So I'm going to divide this side by the 4 also. So K is going to equal 6 divided by 4, which is 1.5, which you'll see is just our Y divided by the X. Our Y is 6, our X is 4. Y divided by X will always equal the K. Y divided